History remembers the headlines, we find the bylines. This is the unsung. When the world learned how to split the atom, a discovery that led to both nuclear power and the atomic bomb, the credit was given to one man, Otto Hahn, who won the 1944 Nobel Prize in chemistry. But behind that headline was a woman in exile, a Jewish physicist named Lise Meitner, who had done the essential theoretical work that explained why the atom split. While Hahn conducted the experiments, it was Meitner who interpreted the data, named the process fission, and calculated the energy released. Yet when the Nobel was awarded, her name was nowhere to be found. So how was the co-discoverer of one of the most consequential scientific breakthroughs of the 20th century erased from its history? Lise Meitner was born in Vienna in 1878, at a time when women were barred from university. But she was a force of nature. She fought for an education, earned a PhD in physics, and moved to Berlin in 1907 to work with the legendary Max Planck. It was there she began a 30-year collaboration with chemist Otto Hahn. Their partnership was a perfect match of experimental chemistry and theoretical physics. Meitner wasn't just a collaborator. She was a leader. She became the head of the physics section of the prestigious Kaiser Wilhelm Institute, publishing groundbreaking work on radioactivity and nuclear physics. She was a giant in her field, but in 1938, her world collapsed. As a Jew living under Nazi rule, her life was in imminent danger. She was forced to flee Germany with nothing but a small suitcase and the clothes on her back. Finding refuge in Stockholm, she continued her life's work, staying connected to Hahn and their research through a series of secret letters. The pivotal moment came in December 1938. Hahn, back in their Berlin lab, was conducting an experiment they had designed together, bombarding uranium with neutrons. He wrote to Meitner, completely baffled by his results. Instead of creating a heavier element as expected, he found traces of barium, a much lighter element. As a chemist, he knew what he had found, but he had no physical explanation for how it could possibly be there. It defied the known laws of nuclear physics. How could a heavy uranium nucleus suddenly produce something so light? The answer came to Meitner during a winter walk in the snowy woods of rural Sweden. She was discussing Hahn's strange letter with her nephew, Otto Frisch, who was also a physicist. As they walked, a revolutionary idea struck her. She pictured the uranium nucleus not as a hard, solid ball, but as a wobbly, unstable liquid drop. She realized that when struck by a neutron, the nucleus could stretch, constrict in the middle, and then split violently in two, just like a biological cell dividing. She even gave the process its name, borrowing from biology: nuclear fission. But she didn't stop there. Meitner realized that if the nucleus split, the two smaller pieces would have a slightly lower combined mass than the original uranium atom. Where did that missing mass go? She immediately turned to Einstein's famous equation, E equals mc squared. She and Frisch did the calculations right there on scraps of paper. They found that the tiny amount of lost mass was converted into a colossal burst of energy. This was the source of the immense power locked inside the atom, the very foundation of both nuclear reactors and atomic weapons. She had not only explained what happened, she had calculated its earth-shattering consequences. Hahn rushed to publish his experimental findings in the German journal Naturwissenschaften in January 1939. Fearing the Nazi regime, he made a fateful decision. He published without including Lise Meitner's name as a co-author. He claimed the discovery was his alone. Weeks later, Meitner and Frisch published their theoretical explanation in the journal Nature, but it was too late. The scientific community had already seen Hahn's paper. The narrative was set. The world credited Otto Hahn as the sole discoverer of nuclear fission. The damage was done. So how did this happen? Meitner's erasure wasn't an accident. It was a combination of scientific sexism, political cowardice, and deliberate omission. First, there was the pervasive gender bias of the era. In the early 20th century, even a physicist of Meitner's stature was often seen as subordinate to her male colleagues. In later interviews, Hahn often referred to Meitner as his assistant, despite her being his intellectual equal and the head of her own physics department for decades. She provided the theoretical framework. He performed the chemistry. They were partners, but history only remembered the man. Then there was the chilling effect of Nazi politics. Hahn, though not a Nazi himself, was working in Germany under the Third Reich. He was keenly aware of the danger of being associated with a Jewish colleague. even one in exile. Removing Meitner's name from the Fission paper was a calculated move to protect his own career and standing within the German scientific establishment. It was a betrayal born of fear. The final injustice was delivered by the Nobel Committee. When the Nobel Prize for Chemistry was awarded for the discovery of fission in 1944, it went to Otto Hahn alone. Lise Meitner was completely ignored. In her lifetime, she was nominated for a Nobel Prize an incredible 48 times, a record for a woman that still stands for physics. But she never won. Declassified Nobel records reveal a shocking bias within the committee. Some members argued that Meitner's theoretical insight wasn't as prize-worthy as Hahn's experimental chemistry, fundamentally misunderstanding that one was meaningless without the other. In the post-war years, the historical narrative hardened. Hahn was celebrated as a good German who had stayed and done important science without collaborating with the Nazis. Acknowledging Meitner, a Jewish refugee forced to flee, would have complicated that clean, simple story. For decades, textbooks and encyclopedias credited Hahn as the sole father of fission. Lise Meitner was reduced to a footnote, if she was mentioned at all. Fortunately, history is a living thing, and the record can be corrected. The re-evaluation of Meitner's legacy began in the 1960s, as historians and scientists, particularly women in science, began digging into the archives. They uncovered the letters between Meitner and Hahn, which clearly showed her indispensable role in the discovery. Slowly, the truth began to emerge. In 1992, in a fitting and permanent tribute, element 109 on the periodic table was officially named Meitnerium in her honor. She is one of the very few women to receive such an honor. Today, Lise Meitner is rightly recognized as a pioneer of nuclear physics, a brilliant mind whose work was obscured not by a lack of evidence, but by a system that was all too willing to overlook her because of her gender and her religion. Her story is a powerful reminder that scientific discovery is rarely a solo act. It's not just about who does the experiment, but about who has the vision to understand what it truly means. Who are some other overlooked thinkers whose crucial insights were credited to others? Share their stories in the comments below. Let's keep finding the bylines. Thanks for watching, and don't forget to subscribe to the Unsung.